Hi folks, this time we are going to talk a little bit about static electricity. Now remember, static electricity is electricity that is not yet moving. This is the electricity that is produced when you have two insulators, non-metallic things that are rubbed together. I know you've experienced this in life. Sometimes you experience it by doing nothing more dramatic than walking. You're wearing two different kinds of fibers, two different kinds of cloth, and the act of just moving and walking down the street rubs these two materials relative to each other. And when this happens, the outside layer of electrons are loosened between those two materials. Now, sometimes you do this on purpose. You rub your feet on the carpeting, and then you touch a doorknob, or you touch your little brother, or you touch the cat, which would be naughty, and you get a spark to jump. We get static electric charges built up in a dryer. You have lots of different fabrics, lots of different non-metallic materials that are rubbing against each other. Another common place this happens, specifically in the winter, is you go to slide out of your car seat, and your clothing versus the car seat rubs against each other, and you get a static charge. So once those outside layer of the atom, which we know is full of those electrons, you take these two non-metallic things, so they are insulators, so they don't conduct charges well. When they get a charge, they hold on to it. So there is this tug of war between these two materials, and as they rub back and forth, these electrons get loosened. Then the two materials, one of them has a greater affinity for the electrons than the other. The electrons that are loosened between the two materials have a greater pull or attraction to one material than the other. And that leaves one material with a slightly negative charge and the other material with a more positive charge. Once that occurs, you have that positive and negative, and in electricity, opposites attract. So if you rub a balloon on fur, after that rubbing occurs, the electrons pick a side, sort of, and then you have a negative and a positive, the opposites attract, and you get an attraction between there. And you can put balloons on the cat, which this cat looks rather annoyed, but doesn't look hurt by that whole process. This is the big rule in electricity, and make sure you know this, and you probably do, but definitely make sure you know it. Like charges repel. If you have two positive charges, they're going to want to get away from each other. It's also true if you have two negative charges, they're going to want to get away from each other. Unlike charges attract, so a positive and a negative will attract, and two like charges are going to repel. Now, this photo of this small child looks like it was taken inside of a tent or something like that. The child was probably crawling around on the floor of the tent, and her clothing versus the floor of the tent, there was probably that rubbing that occurred as she crawled along, tug of war of electrons, and we don't know. Here's the interesting thing about static electricity. We don't know if her hair is all negatively charged, or if the rubbing back and forth, her hair is all positively charged. All we can tell from this picture is that her hair all has the same charge and hence repels itself. Now, how do you get rid of a static electric charge? You can get rid of it by grounding. Now, grounding in electricity means you allow excess charge to flow into or out of the earth. If you need extra electrons, they can flow from the earth into you. If you are carrying excess electrons, they can flow from you into the ground. Grounding means that the electrical charge can flow either direction, but that excess charge can flow into or out of the earth. It has to come through a conductor, or it must have a high enough voltage to jump through an insulator like lightning. When you have something like a vehicle, well, you've got rubber tires, which are an insulator, along concrete or asphalt, which is also an insulator, and you go down the road, that's a lot of rubbing that can occur. Automobiles can pick up a static electric charge. There are grounding straps that can be kind of decorative and interesting you can put on trucks or cars. especially if a vehicle is going to handle some sort of a fuel, gasoline, diesel fuel, something flammable. They are going to definitely have a ground strap that has to be well grounded before that fuel is dispensed. Otherwise, there is the risk of a spark jumping and possible ignition of the fuel. Air is a good insulator. It takes a lot of power, it takes a lot of energy to jump a spark in dry air. Matter of fact, if you ever see a spark jump 1 inch, 1 inch in dry air means that the spark has 25,000 volts. So if you've got a spark that jumps from your finger to a doorknob or your finger to your little brother, 1 inch is 25,000 volts, or it's 10,000 volts per centimeter. That is another number that's very convenient. In lightning, there are different schools of thought. If it is the raindrops rubbing against the dust particles in the air, I've heard some people say it's the raindrops rubbing against the ice particles in the air, but there is a lot of objects that are non-conductive that are rubbing against each other, and this is causing a release of electrons and release of charged particles. Well, these charged particles are produced just like rubbing your feet on the carpet. These tend to build up. Air is a good insulator, so you have to have a big amount of electricity before it jumps. And a bolt of lightning can be as much as 100 million volts. It is a huge amount of electricity, and that is why it can be tremendously deadly. When we're talking about static electric sparks, they can be fun to play with, just when you're messing around with your family and the people you love, but they can also be very, very dangerous when you're dealing with electronics. People who play with electronics, who build electronics, repair electronics, they will have a ground strap that they will wear to make sure that they have bled off the static charge from their body before they start messing around with computer chips. Just due to moving and living, it is most of the time you and I carry around on our person about 10,000 volts of static charge. You may have seen this if it's dark and you pull a sweater over your head, or something as simple as pull a t-shirt over your head and it's very, very dark. You may have seen little static sparks in the dark, and that is just due to the static electric charge that you have accumulated on your body. If you have ever had a cell phone that, especially in the wintertime when it's very dry, and you slide that cell phone into and out of a pocket, like a nylon windbreaker, something like that, you can build up a big static charge. Little tiny sparks can jump and you can fry the computer chips in that phone. So just be aware that it can happen. If you've got electronics that die and you go, why did it die? Well, static electricity could be the culprit. Why is there a lot less static in the summer than there is in the winter? Water. Water molecules, as we've talked in the past, water molecules are polar, meaning one end is different than the other. Most of the negative charges tend to hang on one end of the water molecule, while the positive charges have a tendency to hang on the opposite. So when there is a lot of water molecules in the air, as in the summertime, high humidity, if there's a static charge built up, the water molecules will come along, steal away that static charge, and it's going to be a lot less in the summertime. Wintertime, it tends to be very, very dry. Static charges build up, and you're much more likely to get hair like that when you pull your sweater over your head. All right, that will do, and we'll come back next time. See you later. Bye-bye.